Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 2, being done literally minutes after bonus weather video number 1, as we're catching up here for lost time. And this bonus weather video was motivated by, at least in my mind, the surprise rain that we saw last Saturday night when areas picked up anywhere from 1/10 to 1/4 of an inch. Now, I initially posted this just a few minutes ago and I thought back on it and I just didn't like the way I explained something, and so I deleted it, and now we're doing it again, and this one should stay up there for eternity, or at least close to that, because I think I'll be able to explain it a little bit better. So let's go on ahead and put myself down here in the corner. So we're going to look at a frontal boundary from two different perspectives here. Now, for those of you that are new to meteorology or new to being a weather enthusiast, this L represents an area of low pressure. You have a warm front extending off to the north and east. Basically, this whole sequence here, from the warm front to the cold front, represents the boundary between warm air here, where's my cursor, there it is, warm air on this side of the boundary, from colder air up in here, okay? So the winds go counterclockwise around a low in the northern hemisphere, and they basically, not exactly, but basically follow the isobars, which are these black lines here. And isobars are lines of equal pressure, iso meaning equal, bar referring to barometric pressure. And the closer the isobars are packed together, the stronger the wind blows, because the differences in pressure over a given distance is the force behind what drives the wind. So the bigger the pressure difference over a given distance, the stronger the wind's going to blow. So basically, the wind is blowing parallel to these isobars around this area of low pressure. Warm air is advancing northward here, cold air is advancing southward here. So supposing we're in this location and the wind is basically blowing like this, then I call that isobars running away from the front, okay? Now, there's still convergence going on right at the front, and the reason that's important is when air comes together, it can't go down because you got the earth there, so it has to go up, and if moisture is sufficient, that rising motion produces cooling, you get cloud formation, raindrop formation, snowflake formation, whatever, and you go from there. But in this, from a moisture transport standpoint, the winds are either blowing parallel to the front or actually a little bit away from the front, okay? And so this is why a lot of times you can get lines of showers and thunderstorms well out ahead of the front, because of the fact that the moisture transport is actually higher ahead of it than it is right along the front. But there still is convergence going on right along the front, and I wanted to talk about that. So supposing you have a cold front like this and you have a northwest wind behind it, well, you can split that northwest wind up into two components, okay? An east-west component and a north-south component. So here's the north-south component, okay? And here's the west-to-east component. Now, on the other side of the front, we have a southwest wind, and the east-west component's like this, and the north-south component is like this, or south to north, if you will. So the west-to-east component looks to be very similar on both sides of the front, right? So you're not really getting a whole lot of convergence there. But the north-south component, you've got a straight northerly wind here and a straight southerly wind here. So if you imagine, this arrow right here and this arrow right here, there's definitely convergence going on along the front, and you really can't see that well unless you split the wind up into its two components. So I wanted to mention that real quickly. Okay, so now we go to scenario 2, where we're positioned to the north and east of the low as opposed to being to the south and west of it. Now we're right along the warm front, and the winds are blowing like this, and I call this isobars feeding the front, okay? Excuse me. So moisture is being transported directly into that area of convergence, and then on the cool side of the warm front here, this warm air is being forced to ride up and over the colder air, which is more dense, and so you'll get a large area of precipitation here to the north of the warm front. So you may get showers and thunderstorms right along the front, and then a general area of steady precipitation up in here. And so where we were on Saturday night, we were just to the north and east of a weak area, not a strong one, but a weak area of low pressure, and there was just enough moisture present so that moisture transport right into the frontal boundary was enough to produce those areas of rain, which far exceeded my expectations for that night. So going forward, every time I see this particular pressure pattern, it's going to get my attention, And then at that point, I have to decide, but is that enough? Is there enough moisture present with that configuration to produce rain? That's always the challenge when it comes to weather forecasting. Is it isn't just systems, it's systems and then how many resources does that system have available to it? And a lot of times that's the toughest thing to diagnose. Okay, that is bonus weather video number 2 for this week. Number 3 will be coming up on Friday, and the next daily weather update, of course, later this afternoon. So you all have a great rest of your afternoon, and we'll talk to you soon. See you later, everybody.